Hello and welcome to our tutorial on stream order classification in QGIS. So let's go to this picture to see how best we will explain. This is stream ordering and this is the Strahler method. So there are several methods we can use to uh, classify our streams according to their order, but the Strahler order is a prominent method. So in this example in this diagram, is an example generated from the Strahler method. So let's begin by giving a brief explanation of what stream ordering is. So stream ordering is a way to classify uh, streams in a network according to their sizes. So let's imagine, as in this case, that streams are like three branches. The smaller streams, which in this case are the ones in blue and labeled 1. So the smaller streams with no branches starts as order 1. So as you can see, they are at the very beginning of this network. So they start as order 1. So when two order 1 streams join, they form order 2 stream. So these two order 1 streams have joined and they have formed an order 2 stream. And this order 2 stream plus these other order 2 streams have joined to form order 3 stream. And these two order 3 stream have joined to form order 4 stream. So this is just a basic explanation of the logic behind stream ordering. I'm sure your next question will be, how can you apply stream ordering in your work as geologist? So I will be explaining um, in the context of mineral exploration, but stream ordering is important in varieties of fields, especially environmental science. But as we have agreed to try as much as possible to focus on mineral exploration, I will be explaining the importance of stream ordering in mineral exploration. So, geologists like yourselves often collect stream sediment samples to use it to detect geochemical anomalies. And from our background in mineral exploration, we should know that geochemical anomalies are just traces of minerals. So knowing the stream order matters because higher order streams in the context, this stream order 4 is the highest order stream in this network. So higher order streams mix sediments from many tributaries, diluting anomalies. So whatever sediment you collect here from this stream, the 4th order stream, will be a mixture of sediments from all these many tributaries. So because it is a mixture of all these many tributaries, you could say that it has been diluted because it has mixed with sediments from many different tributaries. But in contrast to, for example, stream order 1, in contrast to stream order 1, here the whatever um, samples you collect from here are closer to the source of your mineralization and therefore provides more precise geochemical signals. So the lower order streams are closer to the source of your mineralization. That is why in mineral exploration, the focus is mostly on lower order streams as compared to the higher order streams. So in conclusion, I would say stream ordering is important in mineral exploration because it guides sediment sampling strategies and help us trace mineral anomalies upstream. And upstream in this context, as I'm sure you know that when I say upstream, I mean to the source of the mineralization. So I hope I provided a clear and brief explanation of what stream order is and why it is useful in mineral exploration. Now that we've done with the literature, let's go to QGIS and see how it is done. The first thing I want us to do here is to try to rectify the errors we have been getting whenever we try to run Saga in QGIS. So as usual, let's begin by installing our plugin. Go to plugins, select manage and install plugin. I'm sure that most of you have already installed this plugin, but for the purpose of completing this tutorial, I will just have to go through all of the processes so that nothing is left behind. Uh, just in case you have forgotten, once the manage and install plugin opens, use this search bar to type in SHEA and then select this processing Saga NextGen and click install plugin. But I have already installed this plugin, so I will just close. If you don't have it installed, just make sure it is selected and click install plugin, and then you can close. So now that we've installed our Saga plugin, let's go and download Saga. So you can open any browser and just type in Saga GIS download. You click on Saga GIS download here in the options that come, and then you will see this green button here that allows you to download the latest version of Saga GIS. So as you can see, once you hover your mouse over it, you will see the version. This is Saga 9.10.0. As if you can recall, the last time we came here, the version here was Saga, I think 9.9.2, something like that. So it's easier to tell that we already have an upgrade in the version of Saga we have here. So I think the last update here is 1 day ago. So this particular version was uploaded 1 day ago. So these things evolve really quickly. And then one thing I wanted us to talk about is the fact that I've been trying to understand why we've been having a lot of errors. So it could be that the processing NextGen plugin that we have installed in this version of QGIS was developed and tested against lower or earlier versions of Saga. So I thought it wise that we should try to download a lower version of Saga and um, try to run it in QGIS and see whether we will get the same error messages. So if you just download here, you will be downloading the latest version of Saga, which we don't want. So go to Files. Once you click on Files, it gives you access to all of the versions of Saga from 9.8.7. So this tool has evolved over a period of time. So we want something from the 9. So under 9, you have all the versions. This is the latest version. So when we came here, we were dealing with 9.92. So since then, they have had 9.93 and now 9.10. So you can see there have been some really quick evolution of this Saga 2. But in our case, we want a lower version. So I think we will be, I suggest that we use something like Saga 9.2.0. So I will click on it and then make sure you select the right file, and it should be a zip file. In this case, I will be downloading Saga 9.2.0 in the zip format. So once you click here, it should download. After downloading, make sure you um, cut or copy it from wherever you downloaded it and locate your C drive. This is my C drive, and just paste it in your C drive. As you can see, it is very important to take note of this. I did not save it in a separate folder in my C drive. I just pasted it directly in my C drive. The next step is to unzip it also directly in your C drive. So I have unzipped it. Here we see it in my C drive, Saga 9.2.0. In this way, you don't have a long link. For example, if we were then linking it to QGIS, the file link will not be very long. Sometimes when the file link is very long, it creates problem for QGIS to identify the file you are trying to link. So now that we've downloaded Saga and unzip it in our C drive, the next step is to go back to QGIS, go to settings, go to options, Make sure this processing is selected here. Otherwise, you won't have the option because we need the providers option. Under providers, go to Sagan, and then Saga folder, go to the far right and click, and then you will see the three dot, which allows you to navigate to your folder. Then you can just go and locate your unzip Saga you just downloaded. Here is it, 9.2.0. Just select it and click select folder. Once that is done, you click OK, and then it is installed. So now that we've done with installing Saga in QGIS, the next step is to import our DEM in QGIS. We have taught you several methods you could use to import data in QGIS. But for the sake of the tutorial, I will just be importing. I will use this browser panel to drag and drop my DEM directly into QGIS. So I will expand my C drive. I know that I have my data saved in a folder called stream order, and I have two different types of DEM. The first one is saved in the folder AP_09028. And this DEM is ALOS DEM. The next one here is saved in the folder called DEM, which are SRTM DEM are downloaded from the United States Geological Survey website. So we will be inspecting the two DEMs to see the difference between the both of them. So I will expand this folder further. I will be beginning with the ALOS DEM. As I open this folder, you see there are a lot of files in here actually, but I will have to be careful and make sure that I input the right file. In this case, the file extension .dem.tif is the right format, so I will just click on it, drag it, and drop it in here. So here we have our DEM. We've imported it in QGIS, so it has appeared in our layer panel. So to inspect it, I will right click on it and go to properties. Right click and go to properties. Go to information, and then I will scroll down. The first thing I want to look at here is the pixel size. So the pixel size, you see 12.5 by 12.5. So this means that each pixel in this DEM has a spatial resolution of 12.5 meters. So let's go to our coordinate reference system. As you can see, the type here is projector. The method here is Universal Transfer Mercator, UTM. And then the units are in meters. Yeah, this is usual for projected coordinate system. The units are in meters. And then the name here is WGS84 UTM Zone 29, which you know covers Liberia. So this is very important because once you are performing stream order classification, it is always important to make sure that your DEM is in a projected coordinate reference system. So this is what we can do with our ALOS DEM. We check the spatial resolution, which is 12.5, and we have also verified that this DEM is already in a projected coordinate system, which means that we can just use it directly without having to reproject it because it is already in a projected coordinate reference system. So we will be closing this, and then let's import the next type of DEM. This is an SRTM DEM I will be importing. So there are four of them here, but I'll be importing the last one. Okay, here is it. So let's go and inspect its properties. So I'll right click and go to properties, and then I'll go to information here. So let's scroll down and see what we have here. The pixel size here, as you can see, is 0.00277, which shows that this is in degrees, decimal degrees. It is also an indication that this particular DEM is in a geographic coordinate system. As you can see the information here, the name here is WGS84. So there are things we have to take into consideration now. If we are using this DEM to perform our stream order classification, we will have to reproject from this geographic coordinate reference system to a projected coordinate reference system. The next thing here is the pixel sizes. I told you earlier that SRTM DEM has a spatial resolution, or SRTM DEM in this case here should have a spatial resolution of 30 meters, but here you have 0.002, which these numbers are in decimal degrees, but this 0.00277 actually equates to 1 arc second, and 1 arc second at or near the equator, where you should be aware that Liberia is at or near the equator, and this dam was downloaded in a region in Liberia. So since this number equates to 1 arc second, and 1 arc second at or near the equator actually equates to 30-meter resolution. So in short, this dam has a spatial resolution of 30-meter resolution, and it is in a geographic coordinate reference system. So if you are performing this analysis on this dam, you will have to reproject it. So I already taught you how to reproject a dam. In case you have forgotten, all you need to do is to go to raster, go to projection, go to reproject. Make sure in this input layer, the dam you want to reproject is the one selected here. And then go to target CRS. Once you click here, if you have already used your preferred projected reference system, it should be here. It should be an option that you can pick. So in this case, I've already used the projected reference system that covers Liberia. So it is an option here that I can pick. But in an instance where you don't have the option, you can just click the globe icon and then come here. Make sure here this, for example, if you had a no CRS here, you won't be able to you won't be able to search for the coordinate reference system of your choice. So you just have to go to predefined CRS, and then it brings all this search bar where you can type the EPSG code for your coordinate your projected coordinate reference system that you want to use. In this case, it is 32629. Once you type it in, you have the option. You can choose run, and QGIS will run and just display the output on the fly. Displaying the output on the fly means that QGIS will display it, you will see it, but then it will not be saved on your computer disk. So whenever you shut down QGIS, that data is lost. So if you intended saving this data, you just select here and click on this arrow that pointing towards back. It takes you back, and then you can come here to this projector, save to temporary file, and change to save to a particular file where you can navigate to your working folder and then save it. For example, you could save it. I told you to always try to be creative with your names. You could say reprojected dam or give it whatever name that makes sense. So I will not be using this dam, but I have shown you how to reproject it. So I will just close, and then I'll remove this because I want to use the alloplacer dam for this stream order classification because it has a higher spatial resolution and it is already in a projected coordinate reference system. So now that we've done with comparing the two different types of dam we have, the next thing is to start having access to the tools we need to uh, classify our streams into the various orders. So go to processing, select toolbars, and then it provides us this option. So you don't have to memorize where each of the tools are because here there are so many tools here. So the first thing you want to do is just know the name of the tool you want to use. The first step here is to do some corrections on this dam because once you download this dam, there are sinks or voids in the dam, but there is a tool here that we can use to make correction to those voids in the dam, and then the tool we'll be using to do the correction is the fill and sync tool. So just type in fill, and then it will give you the option. The full name is fill sync, so double click on this tool. By default, we have our alloplacer dam already selected here because it is the only dam we have in QGIS right now. But if we have several dam, you will have to click here to make sure you select the right one. So QGIS is also going to provide us other output that we probably do not need. For example, watershed basin. I don't need a watershed basin, so I will uncheck it. here, I mean, this is the watershed basin. Here is the flow direction. I already uncheck it. All we are looking for here is to make correction to our dam to fill in the void. So I will click here to go to save to file and make sure I save it as FILLED fill underscore DEM. I will click save, and then I will leave this one as default and just run. This computer is relatively slow, so as you are watching this video, you don't have to wait for the process to complete. You are at liberty to forward the video, because it could be really boring if you are just sitting and waiting for this long um, process to complete. So for those of you with better computers, it shouldn't take long for this process to complete. But in my case, I'm not using the best computer for these kinds of analysis, so it will actually take a longer time. And another reason here is I'm using an entire scene of digital elevation model. Uh, as I taught you before, you could actually subset or extract a portion of the dam and run your analysis on it. But in this case, I did not use a shapefile or a polygon to extract portion of this dam. I'm using the entire scene I downloaded, so it will take an even longer time because of the size of the data I am processing. So while trying this exercise, if you have your dam and you have uh, an area of interest that you are interested in, all you have to do is to extract that particular area, and then it will limit the length of time it takes QGIS to complete the process. So um, just take heed and know that this will be uh, taking a longer time to process, because uh, the size of the area I am processing is actually large, and then the computer I'm using is not the best for processing raster data. But the most important thing I see here is the fact that QGIS seems to be running fine. Saga 2 in QGIS here seems to be running fine. I just hope your experience is the same, because there is no point creating this tutorial if you are not able to run it on your own computers, because you keep running into errors. So just try and install Saga the same way I did it, and hopefully um, you will be good to go. So let's compare between the original dam and the dam we just ran the analysis on. The original dam here, the lowest elevation we have here is 287 meters, and the highest elevation is 1,411 meters. For the corrected version, we have the lowest elevation here is 296.148 meters, and the highest elevation is 1,411. So you can already see some subtle changes from the original dam we imported to the one we just did the correction on. So going forward, we will be using our corrected version, because this is what we've already corrected all of the voids on. So I have unchecked the original dam, and then the next step here is to run our Strahler Auto tool. So just type here Strahler. So select Strahler Auto, double click on it. Make sure your fill dam is selected in here, and then I will just click here to save the output, and I will name it Strahler, Strahler, Strahler underscore ORTER, and then click save. So I will just click run. Again, this could take quite a long time, so just be patient. From my end, I'm just hoping that it doesn't give error messages, because that is the most frustrating part. But I'm pretty confident that it will work, and hopefully it will also work for you. But just in case it doesn't work for you, let me also clarify that even though Saga can be embedded into QGIS to be used as tools in QGIS, Saga GIS is a separate software. It can be downloaded and installed separately and run separately as a software. So if this experiment of using Saga tools in QGIS doesn't work, we may have to download and use Saga as independent software where we can run the same um, hydrological um, applications in Saga GIS to generate our stream network. But try this and let's hope that it works. If it doesn't work, then we can look at other options. But the lower or the earlier versions of Saga that we downloaded should work. If it does not work, you can also try um, because I'm using QGIS 3.44. You could be using a different version of QGIS, so you could also try a lower or an earlier version, or a version earlier than this one, and see if it works. So it is still in process. There is some level of noise in the background, I think from one church or something. I hope it is not reducing significantly the quality of this audio or this video. So um, it is really slow. On a better computer, this could have been done already because it is not a complicated tool to run, but the computer is just slow. The RAM is small. The processing speed is not very fast, but eventually it will run. So let's wait and see. Okay, finally we are there. So I will click close. Whenever you run any tool, make sure you see this complete uh, before closing. Okay, here is our output. So let me go and uncheck our field DEM. This is what we have. And I think it is really difficult to make sense of this in this particular format. Let me zoom in. So let's go to properties. Let's right click and go to properties. Let's see how we could improve on this. So go to symbology. In the render type, select pelleted or unique values. And then the color ramp, the default option is random color. So QGIS will just assign a random color to your data. But I don't want a random color. I want these shades of blue that represent water. So one that is selected. Okay, here let me say something small here about the render type. I selected pelleted or unique color because or unique value because I want each stream order to have a unique value assigned to it. So I prefer this option. Another person could actually use this single band pseudo color if you know exactly how to work it around. I could use this as well, but I prefer this. This is for me the best option here because it is pretty straightforward. So once I've selected this, selected my color RAM, all I need to do is click on classify, and then let's see from order 1 to let's scroll down. We have up to order 12. So QGIS has generated 12 orders to this data here for this stream we had here. So the next thing you have to do here is just click apply here and then click OK. So I think you can see it looks a lot better than what we had initially. So let's click here to see the legend like table. So you can see um, it runs from 1 to 12, and the darker the shade of blue, the higher the stream order. So the highest order stream are in really dark blue, and the lowest order stream one, for example, they are really light in color. So this is how the strata order analysis runs. But I actually prefer another tool for deriving my stream network. I think I prefer this tool because the output is actually in the form of shapefile. So it gives us a lot of flexibility in what we can do with the output. And the tool is called CHANN. Okay, it is channel network and drainage basin. So I will just right click on it. Make sure your corrective DEM or your field DEM is what is selected here. Here by default, the threshold value here is 5. Let me increase it to 6. Uh, then QGIS also wants to generate our flow direction, which we don't need, so I will uncheck. It wants to generate our flow connectivity. I don't need it, so we will uncheck. It also wants to generate our strata order. I don't need it because we've already generated our strata order, so I will uncheck. So you can already see that this particular tool, you can use it to generate several outputs, including our strata order. So I will uncheck. I've already unchecked the strata order. Next one here, uh, we have drainage basin. So I don't want to generate drainage basin, so I'll uncheck it. Then we'll go here to channel, of course. I want to generate our river channel, so I will just click here and save the output. And I will name it CHANNELS channels. So I will see the save type as shapefile. So this will come in the form of a shapefile. And then send the linear features, they will be polylines. So I will just click save. There are other outputs here that I don't need. For example, junctions. I don't need junctions, so I will uncheck. Here, drainage basins. I don't need drainage basins, so I will uncheck. So we've selected the only output we need here, which is the channels. So we will just run. I'm afraid that this will take a lot longer period to run. So I'll uncheck my strata order anyway because we've done with that. Let's wait and see what the output for this river channel will look like. It seems that it will be painfully slow. So once again, you are watching this video, you don't have to wait for this process to complete. You can forward the video and move to the next step. It's moving really, really slowly. It's like it will take a really long time to complete. If I have the time, I can actually edit this video using the same software I'm using to record it and just cut off some of these processing time so that it will reduce the video length or the length of time it will take to for you to watch this video. But it is possible that I will not have the time to edit this video. So once you are watching, you can just forward so that you don't have to wait for this process or all these processes to complete. So let's be patient. It's actually taking me longer than I expected. Ready slow, ready slow, ready slow. But again, as long as I don't get error messages, I am prepared to wait as long as it takes for this process to finish, and then we can see what the output will look like. Mm, So, so we are still here waiting for this process to complete. Still really slow. Wow, still taking so long to complete. I really hope I have the time to edit this video so that I can cut off some of this long time it's taking to complete this process. Mm. Can you imagine if I were processing satellite images, really heavy satellite images, I will be here forever. Okay, finally it is complete. And then let's close this processing toolbox. So I think you can see the output. Let me zoom out a little bit so that you can see exactly how it looks like. Uh, you can already see that it looks a lot better than what we had from our last analysis. So here we are. It looks better than the output from the Strata other two we ran initially. But we can improve on it further. So let's right click and go to properties. And so we want to assign unique value to each category of stream order. So change from single symbol to categorized. Then the value will be categorizing based on which value? Based on the order of the stream. Uh, so again, let's maintain this random color. We can improve and assign our own colors to it later. So let's just click on classify. So here then we can customize this to our own taste. So let's begin with stream order 1. All you can do is double click here, click on simple lines. The essence of stream ordering is to um, classify our streams according to their sizes. So stream order 1 being the smallest stream, I wanted to have the smallest number here. So I will click the arrow that pointing down to reduce it further. So I have reduced this to 0.06. You could change this color by clicking here and selecting a different color, but I will maintain this color that I have here, and I will just click OK. So stream order 2 here, it is in green. Okay, it is 0.26. The last one was 0.6, so it is bigger than stream order 1, which is correct. So the next thing here is let's see if I can change the color. Okay, I will probably maintain this color here. One that is done. Okay, the size is okay. It is bigger than our stream order 1. So I will just click OK. Then stream order 3, the size I will increase it to 0.46. So this color I want something more unique. So let's say let's come this way. Okay. Let me click OK and see how it looks. Okay. So let's go to the fourth one. Okay. It's always important to remember the number we assign. This is 0.46. So we have to make sure this is bigger than 0.46. So okay, this is 0.66, which is bigger than 0.46. So I will come to this here. I will probably maintain this color. Let's maintain it. So let's go to our fifth stream order. This is red. So we increase it to 0.86. I will maintain this red, and let's see how it will look. So let's go to stream order 6. Okay, I will increase it. The last one was 0.86, so this will be 1.06. Let's see how we could change this color. What is this? Let's see. Okay, in this case, let me use yellow and see how it will look. Okay, we have yellow there, and here. So let's increase this to the last one was 0. I think 1 point something. Okay, there was 1.06. Let's increase this one step further to 1.26. And then for the color, let's see if we could uh, generate a different color. So let me see this one. I think this is unique. We don't have this color here. So I will select this. You can feel free to play around with the colors. Just make sure that you have the contrast in color so that each stream order will show different color. That is the essence of uh, um, um, the whole symbology thing we are doing, going to each stream order and assigning a unique color to it. So you don't have to use exactly the same colors I have here. You can be creative. So once that is done, I will click OK. So we have here all other values. We don't want this one, so I will just click this to delete it. Now I will click apply and click OK. So here we are. You can see. Let me reduce. Let me zoom out a little. So you can see here how we've improved on it. So easier to tell here. These are our largest stream, from the largest to the smallest. So I think it looks pretty good. Let me zoom out a little bit more. Okay. So if this color, for example, this color 2, if it's not showing as good as you want it, you can also change it. Um, let me decide. Okay, let me change this. Let me go back and change this color. This the color for stream order 2 here. I will right click here and let me change it to let me see, this green. Uh, let me see how it will look. Okay, probably. Okay. It is up to you. You could decide what's best for you. Uh, you could decide what's best for you. I could go back here and then look for something different. Uh, nope, I don't want that. So let me use this throw wheel. Let me see. I already have this. Uh, so okay, let's try this and see. Let me click OK. Let me click apply. Okay. Okay. I will just keep it as it is. You are free to play around with the colors, but let's see how we can improve on this further. Let's go back to our field DEM and uh, put it back on. So right click on the field DEM, go to properties, change from single band to single band pseudo color, and then you could invert this color scheme so that the red will go to the bottom and the blue will come to the top. All you need to do is right click in here and go to invert. If that is what you think will look better, because here I just trying to uh, give it a better visual appearance. So once this is done, all you need to do here is click on apply and click OK. So I think it looks even better, but I want to give it a little bit of a 3D view. So to do that, go to raster, go to analysis, and then go to hillshade. Make sure your field DEM is selected here, and then keep everything here using the default value, and then you can save your hillshade you will be generating. So I will just name here hillshade, SHADE, hillshade. I will click OK, and then I will run. Okay, it's complete. So I think you can see, for example, let me zoom in a little bit. So I think you can see it is showing the elevation here quite clearly. You can see here, these are elevated areas. You can see here all the areas that are elevated. You can clearly see them. Here, this place looks elevated. Here is elevated. You can see the low lands. You can see the high lands. So Um, but again, it is too um, distracting to see it in this manner. So we can go to the transparency to ensure that it doesn't become a distraction, because at the end of the day, uh, the focus should be on our stream network. So let's go here, right click, go to properties, right click on your hill share, go to properties, uh, come to transparency. You can reduce the transparency. Let's reduce it to, let's say, 35, and click apply and see. Okay. So we've increased this transparency, we reduce the transparency, and then this is what we have. I think it is better than what we had initially. So let me zoom out a little more. Uh, so this is what we have here. You can play around with the transparency. For example, um, here we have 35. Let me go to 45. Once I go to 45, you see what it will look like as well. So this is what we have here at 45. You can reduce it to 25 and see. Just play around with it until you get exactly what you think is best for you. But normally, normally it is, we tend to reduce our transparency to around 30, 35, or something, depending on what you want from your um, from your data. What do you want to display? So this is our tutorial on stream order um, classification using QGIS. And as I said, I prefer this channel and drainage basin tool. The output here is in the form of a shapefile. In this case, we are dealing with linear feature. This is a polyline, so we have a lot of flexibility in what we can do. So thank you for following. I hope once again that Saga GIS doesn't give errors, so that you will be able to follow the steps and produce something similar on your own. So thank you, and I look forward to meeting you in person.